Worksheet 3.6, Part 2. So now we're looking at verifying the following functions. So we know these when we're looking here. We have pi on 2, pi, 3 pi on 2, and 2 pi. So we know pi plus theta is going to be in this range here. And we know all stations to central. We know that this is going to be negative. But we're going to verify this using these formulas here. So we have cosine of pi plus theta here. And we're going to be using this one here is cosine of pi multiplied by cosine of theta minus sine of pi multiplied by sine of theta here. And we think about our actual cosine curve. So at 0 we're at 1, at pi on 2 we're at 0, at pi we're at negative 1. So cosine of pi is negative 1 multiplied by cosine of theta. And then our sine curve, at pi our sine curve is cutting through the x-axis and so is equal to 0 multiplied by sine theta. So this one will cancel out and we're going to have equal to negative cosine of theta. For our next formula here we have sine of pi on 2 plus theta here. So we're using this formula here will be equal to sine of pi on 2 multiplied by cosine of theta plus cosine of theta multiplied of pi on 2 multiplied by sine of theta. So sine of pi on 2 is equal to 1 multiplied by cosine of theta. Then our cosine of pi on 2 is where we cut through our axis is equal to 0 times sine theta. So we have this is equal to cosine of theta. So for our next equation we have tan of pi minus theta. Again remembering that this formula is written incorrectly here. So we have tan of pi minus tan of theta divided by 1 plus tan of pi multiplied by tan of theta. So at pi our tan is equal to 0. So we have 0 minus tan of theta divided by 1 plus 0 times tan theta. So we end up with negative tan theta divided by 1 or negative tan theta. So for question 3 we want to be using our knowledge of these equations to show that sine pi on 3 plus pi on 4 ends up being root 6 plus root 2 on 4 for 1. So we have sine of pi on 3 plus pi on 4 is equal to, we're using this formula here, sine of pi on 3 cosine of pi on 4 plus cosine of pi on 3 multiplied by sine of pi on 4. So we substitute our values in here. Sine of pi on 3 is root 3 on 2 multiplied by cosine of pi on 4 is 1 on root 2 plus cosine of pi on 3 is a half multiplied by sine of pi on 4 is 1 on root 2. So now we have here we're going to end up 2 root 2. We look here we have a 4 in this equation. So if we multiply by root 2 and by root 2 and by root 2 here. So now we have root 3 on 2 multiplied by root 2 and root 2 times root 2 is on 2 plus 1 on 2 multiplied by root 2 on 2. So here we end up root 3 times root 2 gives us root 6 on 2 times 2 is 4 plus 1 times root 2 is root 2 and 2 times 2 is 4. So we have the same denominator here, and at the top root 6 plus root 2 is equal to our right hand side. For our equation 2 here, we have cosine of pi on 6 plus pi on 4 here. So here we're using this formula here. We're having cosine of pi on 6 multiplied by cosine of pi on 4 minus sine of pi on 6 multiplied by sine of pi on 4 here. We substitute our values in. So we have cosine of pi on 6 is root 3 on 2 multiplied by cosine of pi on 4 is 1 on root 2 minus sine on pi on 6 is a half, and sine of pi on 4 is 1 on root 2. Again, we look at our equation here and we're wanting a 4 at the bottom. So we're going to do the same thing. We're going to multiply by root 2 and multiply by root 2, multiply by root 2 and multiply by root 2 here. So we end up with root 3 on 2 multiplied by root 3 on 2 minus a half multiplied by root 2 on 2. So here root 3 times root 3 becomes 3. Root 2. There we go. So that should be a root 2. That makes more sense. So now we have root 3 times root 2 is root 6. 2 times 2 is 4. Minus 1 times root 2 is root 2. 2 times 2 is 4. We have the same denominator, root 6 minus root 2.